Hi everybody, this is Mrs. Ellsworth, and we are going to be doing a lab where you're going to be calculating your horsepower. Okay, I got two students I know who rides horse quite a bit, and I just want to tell you that, yeah, you got horsepower too. And the rest of you, we're also going to be talking about something called Cami too. And I have got it downloaded on my web browser, and it actually goes in my Google Classroom. And so when I actually can send out a document, I can decide whether it's going to be a Cami document or not. And a Cami document is one that you can go and edit it right on it. Okay, so when I went to the Google store, it looked like this, and I went and got it. It does ask for access to my drive, and that kind of worried me a little bit, but I am a bigger chicken than the rest of you guys on that. But it seems to be just fine. And then then when I went and decided to go and send out this finding your work and power from climbing steps lab, then it asked me if I wanted to open it up. I went and clicked on this, and I'm going to then went and grab something from my computer. So that's how I did that. And so then I can send it out on my Google Classroom. And when I do that, then when I go create a classroom assignment, it's kind of cool because I actually see that I can do a Cami assignment, which means that you can go and edit it. And then later on, when I go in and grab your information, like if I send out this worksheet like I'm going to do here, and you go and edit it, then I actually go and grab a Cami assignment from you. And so I can see your your annotations on it, or whatever you've highlighted, or anything you even wrote on it. So I can see all of it, so it's just like you handing in a sheet of paper. So I want to try this, and if you're going to give up on it and send me another Google document that's a numbered form, that is fine too, but I really, really want you to try this. Let's both learn together on it. Anyway, so let's go back to this assignment. So what the neat thing about this is that you can annotate it here from the side. You can go and draw on it. Okay, so I can go and click that, and I can go and tell you, like, okay, I'm going to be, this first one, I'm going to have a grandchild's weight of 45 pounds, and I just made an error there. I don't know if you noticed that. Anyway, so what you need to do in this lab is that the first thing you need to do is you need to go and figure out your weight. You don't need to tell me your weight, but I'm going to show you how I'd figure this out for my grandchild, because you need to figure out your force, okay, your newtons. So what you're going to do is you're going to take your weight, divide it by 2.2, that's a division sign, not addition, and then multiply it times 9.8. So I'm going to just show you my thinking here. And so I'm going to go and divide it by 2.2, and I'm going to multiply times 9.8. See, I can annotate right on here. Okay, and then I can go and calculate that, and then I can even type in this text box what I want. I put it in the size of 18 there. You can change that. You can put whatever color that they have right here for you. And so when I did that, I saw that my grandson actually weighs 200.45 newtons. Pretty cool, huh? So now we have his force here. So now, not am I only talking about Cami on this, I'm talking about this lab that I'm going to ask you to do to figure out your horsepower. I sent out a message to you saying that I would like you to go and run up some stairs, and you need to measure the length of those stairs, or else you have to do it if you don't have enough stairs. Like just 3 or 4 stairs is not enough. Okay, so if you don't have enough, then where's a spot that you can go run up a steep hill? And I was thinking that the elementary's got a couple steep hills on the west side of the building. Maybe there's something near ditches that you can run up, so that you can figure out a place to run up an area. But you also need to measure how long that this is. You don't need to go much further than like 15 feet, but we got to go and change that from feet into meters also, so you have to do that on Monday. But then also you have to also time it when you run up, so we can figure out your horsepower, because power, again, you got to have, work divided by time, so you need to have that time. Anyway, so when you're doing this form, so I'm going to, like I said again, I'm doing this with my grandson. Okay, if we would have done this in the high school, we would have been doing this over 4.7 meters. So you are not going to be doing 4.7 meters, are you? So unless you just happen to get lucky on that. But so we're going to cross that out. Oops, we are going to cross that out. Okay, and we're going to say that instead that he ran up something that was We'll do 5 meters just to keep it simple for us, okay? So 5 meters. So we're going to take his 200.45, we're going to multiply it because it's force times distance. So we're going to take that 200.45 times the 5 meters, okay? And then we're going to go ahead and put that answer right there. And I just calculated that, and I saw that that was, oh, and I just lost it, times 5 here. Okay, so I saw that that's 1002.27, 1002, okay, you could type it in here or else go and write it in, 1002.27, okay, and then you also need a unit in all of these. Make sure, because each one of these squares are worth 2 points. So you need a unit, and so this right here is work, so work is always in joules. You know, we probably need to also have 2 points for your measurement for that one too. So I will be adding 2 points for that one too. Okay, so then now, what was the time that you ran up there? Well, my grandson was really fast. It only took him 3.6 seconds. Okay, we did it a couple times. We got 3.5 this time. And so we're going to just go with 3.6. And so what do? You take your work. Here's my work. Okay, you take your work, which is 1002.27, and you divide it by the time, and then the time in this case we're going to do 3.6 seconds. I probably should put some units there. Anyway, so then we'll go calculate that. Okay, and I'm going to go ahead and get a text box here, and my answer in here, don't forget you need the number and you need the unit, and my number will be 278.41, and that is in watts. Okay, and so you can get rid of this by clicking on that X. If you stretch this out, it doesn't get any bigger. Okay, it doesn't stretch out. You could make it larger text that way, but this is just fine. Now we want to figure out our horsepower. So you go and take your watts and you divide by the 746, just like it said in your book. Okay, and so let's do that next. I suppose I probably better write this down what we did here so that you've got something to go by when we come back to this. Anyways, so this was the 278.41 watts, and we divided by the 746, and now we're going to get the horsepower, which is 0.37, and most of you guys are going to have quite a bit higher horsepower than that. But again, my grandson is only 45 pounds. Oops, got to turn my pen right side up here. And so this unit, oopsie, I better erase that. I better go get the eraser. Huh? Here we go. There's the eraser. I'll erase that. Okay, and then I'll get back to drawing. And that this is 37 horsepower. HP, capital H. Okay, now, so now you've figured out your horsepower, but you're not done there. You need to go and calculate the horsepower for a man who is 250 pounds. Okay, you'll have to start exactly in the same exact spot. You'll have to go and take his mass, his pounds, divide by 2.2 to get kilograms, and then times by 9.8 to get his weight, which is a force. Okay, and they're going to still multiply times the same length of steps, same amount of time, and so you're going to figure out what is his work, what is his regular power, not asking for horsepower, and then you'll have to talk about, since you know about work and power, you have to talk about ways that you could improve your power. Okay, and then if you're not getting 2 ways here, then go ahead and talk about this right here and compare it to you, and that might help you figure out one of the answers to this too. Okay, so we're going to be running upstairs, or we're going to be running up a steep incline. You need to measure how long it is. Okay, if you do not have a tape measure, lots of our feet are around 12 inches. So, I mean, I know that that's not perfect. But still it is something. I hope that you do have a tape measure. They usually go 25 or 15 feet, and you'll have something to go by. But that's what I got for now for our lab that we're going to do on Monday. You might want to get some information on that a little bit sooner. Bye-bye.